We're looking at section 9.3, solving rational equations. So we want to be able to solve simple rational and radical equations in one variable, as well as give examples showing how extraneous solutions may arise. So one possible way we can solve rational equations is graphically. We can use a graph to find solutions. First thing we always want to look for are the excluded values. Those are the possible values that can't work as a solution. And we're always looking in the denominator of our fractions to see where the denominator is equal to 0. So in this case, we're seeing where x minus 3 is equal to 0, which gives us our excluded value, x equals 3. So 3 is an excluded value of the rational equation. Next thing we want to do is rewrite the equation with 0 on one side. So in this case, we'll have to subtract the 2, which will leave us with x over x minus 3 minus 2 is then equal to 0. So we want to graph the left side of the equation as a function. We'll substitute y for 0 and complete the table below. So plugging in those values for x, these will be the solutions that you get. Now, obviously, if you have a graphing calculator, that would be a much easier process to do. Just plug that equation into your calculator. And then our solutions, we're looking for where's the function equal to 0. So we're looking at where are we crossing the x-axis, because that's where the function is equal to 0. So we can graph these coordinates here: 0, negative 2, 1, negative 2.5, 2, negative 4, 4, 2, 5, and 1/2, and 9, negative 1/2. So we can kind of get the general shape here based on our coordinates. So again, the key thing we're looking for here is where do we cross the x-axis? That's where our function is equal to 0. So we're looking for the x-intercept of the graph. In this case, the x-intercept is at 6, 0. So we're checking the value of x. Is this value an excluded value? So is x equals 6 excluded? Well, no. X equals 3 was the only excluded value. So that means our solution here would be x equals 6, because it is not an excluded value. So why does rewriting a rational equation with 0 on one side help with solving? Because when we graph, the solution is where the function crosses the x-axis. So that's going to be our solution if we were to solve these graphically. Our focus, though, is on solving rational equations algebraically. So they can be solved algebraically by multiplying through by the least common denominator and solving the resulting polynomial equation. However, this eliminates the information about the excluded values of the original equation. Sometimes an excluded value of the original equation is a solution of the polynomial equation. In this case, the excluded value will be what's called an extraneous solution. And extraneous solutions are not solutions of an equation. So these are one time you will need to check and make sure your answer for sure is a solution or not a solution. So let's say we want to solve this equation algebraically. So first you identify any excluded values. So we take the denominators from each of those fractions, set them equal to 0. In this case, the excluded value is going to be 5. So then you want to identify the least common denominator by finding all of the factors of the denominators. So the factors are 2 and x minus 5, so that's going to be our least common denominator. So what you can do is multiply each term by the least common denominator, and then simplify and solve for x. So in this case, they got the value x equals 3. It's not excluded, so that means x equals 3 is the solution to the equation. So here in part B, first we want to do is identify any excluded values. So x equals 7 equals 0 would get us an excluded value of x equals 7. So that's our excluded value. Next, we want to identify the least common denominator. So the different factors are 2 and x minus 7. So our LCD is going to be 2 times x minus 7. So if we multiply each term by the LCD, so multiply each of these by 2 times x minus 7, and then we can divide out the certain pieces here that are going to cancel. So the x minus 7s are going to go away there. The 2 is going to go away there. X minus 7s are going away there. So when we simplify here, we'll have a 2 times the 2x minus 9. We'll have the x times the x minus 7, and 5 times 2. So we distribute, we'll get 4x minus 18 plus x squared minus 7x is equal to 10. We rewrite it in standard form. So we'll end up with x squared minus 3x minus 28 equal to 0. So since we have a quadratic, we can factor it. Factors to become x minus 7, x plus 4 equals 0. So we use the zero product property, set each of those factors equal to 0 to get our two solutions, which are 7 and negative 4. However, the solution x equals 7 is extraneous because it is an excluded value, which means we'll only actually have one solution here, which is that x is equal to negative 4. So if we want to solve this rational equation algebraically, first thing we look for are the excluded values. So in this case, our excluded values, x can't be negative 3 or negative 6. We set each of those factors in the denominator equal to 0. Those would be our excluded values. Our LCD in this case is just going to be the product of those two things. So x plus 3 times x plus 6. So the method the book likes to use here again is multiplying both sides by the LCD. So I have 8 over x plus 3 times x plus 3, x plus 6 is equal to x plus 1 over x plus 6 times LCD x plus 3, x plus 6. So now you can see the terms that are dividing out. So we're left with 8 times x plus 6 is equal to x plus 1 times x plus 3. If you distribute that 8, we'll get 8x plus 48 is equal to this distributes to become x squared plus 4x plus 3. So we want to get everything on one side, write it in standard form. We'll end up with 0 is equal to x squared minus 4x minus 45. So from here we can factor. Should factor to x minus 9, x plus 5. So we're going to get two solutions here of x equals negative 5 and x equals 9. Now neither of those are the excluded values, so those would just be the two solutions to this equation. So there's kind of another method you can use to solve these. I'll show that here in just a second. First thing we want to do, find the excluded values. Well, before we do that, we have to factor this denominator here. Well, it actually factors to x minus 6, x minus 7. So that means our excluded values would be positive 6 and positive 7. And our LCD is x minus 6, x minus 7. So kind of a different strategy you can use. It's essentially doing the same thing we did before. What you do is you figure out your LCD and figure out what piece is missing from your LCD in each of your terms. So in this case, we have the 9 over x minus 7. If you figure out what piece is missing from your LCD, we're missing the x minus 6. So if you multiply by x minus 6 over x minus 6, then you'll have your LCD. Minus 7 over x minus 6. So it's missing the x minus 7. So we'll multiply by x minus 7 over x minus 7. Now in this case, on the right-hand side here, our LCD is already good. X minus 6, x minus 7. Once you have the common denominator, you can actually just get rid of the common denominator and focus just on the numerators. It's actually doing the same process. It would be essentially if we multiplied everything times the LCD. It would get rid of all of the denominators on everything. So you can use this process if you would prefer, then multiplying everything times LCD. That's what I normally do. Figure out which piece is missing the denominator, multiply it, and then now we could just focus on the numerators. So we'll have 9 times x minus 6 minus the 7 times x minus 7 should be equal to 13. And we'll continue solving this problem in the next video.